Hold on to your hats, because this is a seismic shocker, literally and figuratively. In a jaw-dropping event that scientists are calling rare and complex, Japan has suffered not just one, but two massive earthquakes mere minutes apart near the Japan Trench. The first hit with a magnitude of 7.8. The second followed almost immediately with 7.6. Two seismic behemoths, stacked back-to-back, on a trench that's already one of the most dangerous and tectonically restless places on Earth.
If you enjoyed this breakdown, don't forget to like, subscribe, and drop a comment. Your feedback helps shape what we cover next, and you being here keeps the conversation going. Thanks for watching. See you in the next one.
Think of it as the Earth cracking open its own warning system and cutting loose. The coastal prefectures of Miyagi Prefecture, Fukushima Prefecture, and Iwate Prefecture bore the immediate brunt. Evacuations underway, tsunami alerts flashing, and people fleeing to higher ground while Japan's famously precise early warning system splintered into a race between nature and technology. What makes this double strike so alarming and so tricky is the twin rupture pattern. In most big quakes, one fault ruptures, slips, releases energy, and we brace for the aftermath. Here, two faults slipped almost simultaneously, transferring energy between each other, complicating matters on how the seafloor moved, how water would displace, and how a tsunami might form, behave, and strike. That means the traditional playbook for dealing with a big quake, followed by a tsunami, is now a bit outdated. Scientists are scrambling, analyzing seismic waveforms, checking ocean bottom sensors, monitoring tide gauges, and scanning satellite imagery to trace every millimeter of seabed displacement. Because when you have twin ruptures, especially where the trench is involved, the tsunami hazard doesn't just double, it changes its nature. Wave heights can be greater, travel times unpredictable, and aftershock sequences can trigger secondary tsunamis. For coastal communities, that means the threat is far from over. Japanese authorities are not letting their guard down. The country has decades of experience, from the catastrophic 2011 Tohoku quake onward, so they know that just because a big shake has stopped doesn't mean the danger has. Prime Minister Fumio Kishida and the emergency response teams are reminding everyone, stay evacuated, stay alert for aftershocks, expect erratic waves and swelling sea levels for the next 48 hours at least. And while the worst tsunami waves may already have passed, the underwater saga is still playing out. The trench lock segments remain dangerously stressed. The twin event may be just the beginning of a round of adjustments. Every microquake, every minute shift in the seafloor becomes a data point in a high-stakes game of catch-up. So let's peel back the layers and talk about why this matters, beyond the headlines and the sirens. First, twin ruptures, rare in themselves. Two faults giving way nearly concurrently. That kind of energy transfer is dangerous because it means the seismic zone is acting less like a single crack and more like a fractured network, which means our models, based on one fault breaking at a time, may not hold up. Then, trench involvement. What happens if the Japan Trench doesn't stay at the trench? It radiates. When a trench segment slips, the seafloor moves vertically. That's a trigger mechanism for tsunami. The ocean bed lifts or drops, the water responds instantly, and the shoreline pays a price. With twin ruptures, you've got overlapping displacements, potential for more water to move more quickly, and more areas of coastline at risk. Next, tsunami modeling becomes harder. Because of the unusual rupture pattern, the wave height predictions and timing predictions are less certain. Waves could arrive sooner in some places, or later in others. Some shorelines might see what's expected. Others, they might see a weird, delayed surge hours after people return home. That's chilling. And aftershock and sequel potential. When large ruptures occur, the stress field changes. Faults nearby get pushed, pulled, triggered. That means more earthquakes, and possibly more seafloor disruption. And if there's more seafloor movement, more tsunami potential. So communities can't just exhale yet. All right, what are the scenarios we're watching? Scenario A, the worst of it already happened. The big waves hit, the seafloor settled, the aftershocks are moderate. Evacuations lift within days. Cleanup begins. Japan mourns, rebuilds, studies the event for years. Scenario B, secondary waves. Smaller than the first hit, but still strong. The seafloor keeps slipping in adjacent segments. Shorelines that felt safe might get hit again. Evacuations are extended. Recovery slowed. Scenario C, prolonged seismic activity. The trench segment remains unstable. More faults wake up. A second major quake could occur days or weeks later, potentially even larger. Tsunami hazards remain high. Resources stretched. Risk for entire coastal arc increased. Japanese authorities and scientists are watching all three as live possibilities. Their messaging? Be ready for all three. Now let's dig into what this earthquake tells us about science and about preparedness. Real-time data saves lives. Japan's early warning systems, seismic sensors, tide gauges, satellites have already prevented thousands of casualties by triggering evacuations minutes after tremors. The twin quake situation underscores how vital these systems are, especially when events deviate from the norm. Models must evolve. When nature throws a pattern we didn't expect, the models need to catch up. Twin ruptures challenge assumptions about how energy is released and how tsunamis form. This will likely fuel a wave of research, algorithms, new mapping of trench systems. Preparedness isn't a one-time deal. Japan's long tradition of drills, public education, evacuation shelters is paying off. People know the routine. When the alert comes, move. But this event reminds us that when anomalies strike, following the plan matters. The community readiness component is as critical as the technology. Global cooperation and sharing matter. The earthquake sensors, ocean buoys, satellite data, they don't just serve Japan. They serve the Pacific Basin, the entire Ring of Fire. International agencies are exchanging data in real time. Events like this highlight why seismic risk is a global concern. And finally, for you, the observer, the person reading this while the earth beneath Japan still rumbles, this should feel personal, even if you're thousands of kilometers away. Because Japan's coast is a constant reminder, when you build cities near active tectonics, you're borrowing stability. And when a fault line acts in ways we didn't plan for, the consequences ripple outwards, into shipping routes, into global supply chains, into insurance policies and infrastructure investment around the world. So here are questions worth asking. If a twin rupture event can happen in one of the most prepared countries in the world, how prepared is your region for the unexpected? How would a major tsunami impact your local coast, or the coast of a nearby country, and are the warning systems robust enough? Are your cities and governments treating extreme weather and seismic events as maybe will happen, or when it will happen? Because this is a wake-up call. Not just for Japan, but for anyone who thought the big quake event was well understood and well planned for. The Earth just rewrote a page of the handbook. So let's close with this. The twin megaquakes that ripped open Japan's trench are more than a headline. They are a moment, a crack in the ground that showed us our assumption could break just as fast as the earth beneath our feet. For the people of Miyagi, Fukushima, the ones evacuating, the ones watching the sea like it's a monster they once knew but now fear, they remind us what resilience looks like, preparedness looks like, rapid action looks like. And for the rest of us, it's a challenge, a prompt, a hammer to the complacency that says, we've got this covered. Because sometimes nature answers with a question instead. Will we step up? Will we act? Because when the earth moves like this, it doesn't just shake the ground. It shakes the story we tell ourselves about safety and preparedness. And right now, Japan is showing us a page we didn't expect to turn. Stay alert, stay prepared, and above all, listen to the ground. Because when it speaks, it's often just a beginning. If you're tracking this, want updates, want to dive deeper into how the trenches work, how tsunamis form, how twin ruptures change the game, subscribe. Because the story is unfolding, and we'll be watching it with you. When the Japan trench cracks open, twice, in under 5 minutes, that's not just seismic activity. That's the Earth having a full-blown breakdown right in front of us. What we're witnessing is something almost unheard of, a twin rupture sequence on one of the most volatile tectonic plate boundaries on the planet. This isn't your typical foreshock main shock combo. These quakes were both monsters, independent, powerful, and frighteningly synchronized. To put it bluntly, imagine one hand clapping. Now imagine two hands slamming together at full force from opposite directions. That's the kind of energy we're talking about. And when that kind of motion happens at the bottom of the ocean, it's not just the Earth that responds, It's a C. You know what scientists are quietly whispering behind closed doors? This might be another Tohoku in disguise. Yeah, that Tohoku. The 2011 megaquake that devastated northeastern Japan generated a 40-meter-high tsunami, triggered a nuclear crisis, and altered the tilt of the entire planet. Except now, we have something even more chaotic. Two quakes interacting across separate fault planes, spreading instability like wildfire through the trench system. And here's the kicker. Even the most sophisticated tsunami models struggle with twin ruptures. Why? Because most models assume a single point of failure, a primary energy source, a clear direction of force. But twin ruptures? They are messy, unpredictable. They create what seismologists call compound tsunami signals, where multiple energy pulses merge, overlap, cancel, or amplify. That means waves can behave erratically, with unexpected heights and arrival times. That's why Japan's warning sirens didn't go off once. They kept updating. First a level 2 alert, then level 3, then a localized evacuation in coastal lowlands. Because when the models are scrambled, the only thing you trust is raw data and instinct. Let's talk about that for a second. Instinct. Because while the algorithms processed satellite imagery and tide gauges logged rising water levels, there were people, regular citizens, sprinting uphill, hauling kids, pets, and elderly relatives in tow. Why? Because in Japan, the trauma of 2011 still lingers. People know that hesitation can be fatal. When the ground shakes hard and long, and you're near the coast, you don't wait. You move. This culture of readiness, of learned fear, is arguably Japan's greatest survival asset. But what about the science? What actually happened underground? Geophysicists now believe that the first quake ruptured a deeper portion of the subduction interface, a region of the Pacific plate that's been slowly wedging itself beneath the Okhotsk plate for millions of years. The second quake? Shallower, more violent, closer to the seafloor, and therefore more efficient at displacing water. That's what triggered the tsunami alerts. And here's a terrifying implication. The stress transfer between the two faults may have primed adjacent segments, meaning this might not be over. If there's an unstable zone to the north or south, even just a few kilometers, it could slip next. And that could unleash a third quake, potentially even larger. Right now, Japanese meteorological and geological agencies are scanning every inch of the trench with sonar, GPS, and NSAR data to detect microdeformation. They are not just looking for aftershocks, they are looking for precursors, subtle bulges, strain patterns, acoustic anomalies, anything that hints the next domino is about to fall. Let's pause and talk about a real-world scenario. What would happen if a third megaquake hit within the next 48 hours? First, tsunami models would need to be recalibrated instantly. Shelters would stay open. Emergency services would stretch beyond capacity. Supply lines to isolated towns would snap under pressure. The nuclear reactors along the coast, yes, some are still operational, would shift to maximum emergency readiness. Airports? Shut. High-speed trains? Halted. Internet? Disrupted. But more than that, national psychological stress would skyrocket. Remember, this is a country still healing from the trauma of 2011. A third quake would be more than geological. It would feel like a betrayal from the Earth itself. Again, and what about the tsunami? Let's say, hypothetically, a segment just north of the current rupture gives way. The energy could be funneled into a tight corridor, amplifying wave height. Coastal villages in Amori, Iwate, and even as far north as Hokkaido could be hit with a wall of water before anyone can fully react. And it's not just Japan in danger. This trench system feeds energy into the wider Pacific basin. That includes the Kuril Islands, the Russian Far East, and even the coast of Alaska and Hawaii, which could experience small to moderate wave activity depending on the energy dispersion. So no, this isn't just Japan's problem. It's the planet's. Let's talk for a moment about the why. Why are these kinds of complex quakes happening more frequently? It's a question scientists are still grappling with. But here's a working theory. Climate change is affecting more than weather. As ice caps melt and redistribute the weight of the oceans, pressure on tectonic plates can shift. That change, while seemingly subtle, can alter stress fields and fault systems, especially subduction zones. Combine that with rising sea levels and warmer ocean temperatures, which can affect seafloor sediment density, and you've got a multi-layered cocktail of geological instability. In short, the Earth is adjusting, and sometimes violently. So where do we go from here? First, continued vigilance. Japan's early warning system, arguably the best in the world, is under strain, but it's functioning. Alerts are being issued. Maps are updating in real time. But people must keep listening. Second, infrastructure. We're learning, again, that seawalls can't be the only answer. After the 2011 disaster, Japan spent billions reinforcing coastal defenses. But if the ocean lifts by 5 meters in minutes, walls won't stop it. Evacuation speed and elevation do. Third, education. The average citizen in Japan knows more about tsunami risk than most schoolchildren in coastal North America or Europe. That has to change. What's happening off Japan's coast could easily happen in the Cascadia subduction zone, or the Sunda Trench, or the Chilean coast. This isn't an isolated story. It's a pattern in motion. And finally, research. If there's one clear takeaway from this disaster, it's that we are still learning how the Earth works. The idea that we can predict earthquakes with pinpoint precision? Still a fantasy. But what we can do is get better at preparing, at adapting, at listening to the signs. Because the Earth always speaks first. It rumbles. It shifts. It groans in frequencies we can only now detect. And when it screams, like it just did with these twin megaquakes, we either move fast or we pay the price. So to every coastal town in Japan, hold the line. To every seismologist scanning waveforms, don't blink. And to every country watching from afar, thinking this couldn't happen to them, think again. Mother Nature doesn't play favorites. If you're still with us, thank you for staying tuned in to this incredibly important story. Hit subscribe if you want real-time breakdowns of what's happening when the Earth moves, not sugar-coated news. Just raw, honest storytelling grounded in science, humanity, and a little bit of awe. And tell us in the comments, what would you do if a megaquake hit your coast? We'll be here, watching the trench, watching the tide, watching the science unfold. Stay sharp, stay safe, and never stop listening to the planet. Let's dive even deeper, because the story isn't over. Not even close. As we speak, scientists are still poring over the seismic data, comparing it to models they once trusted, trying to make sense of twin megaquakes that not only defied expectations, but shattered assumptions. One thing's becoming crystal clear. This was no fluke. The twin quakes didn't just shake the land. They revealed just how little we truly understand about subduction zones. These aren't just fault lines in the dramatic movie sense. They're entire planetary systems, hundreds of kilometers long, with intricate pressure points, silent stress zones, and potential energy just waiting for the perfect moment to snap. And now that moment has come. Twice. One moment the sea floor is calm. The next, it lifts vertically, violently, by meters. That sudden push displaces millions of cubic meters of water. The kind of vertical motion that generated the 2011 tsunami, it just happened again. On a smaller scale, yes, but not small enough to ignore. And let's be real here, this could have been worse. Much worse. If those ruptures had been even slightly closer to the surface, if the slip had extended into shallower sediment zones, we'd be talking about an event capable of swallowing towns, entire fishing communities, ports, nuclear facilities. So why did it stop where it did? That's a question everyone wants answered, and no one can confidently say. Because this wasn't just tectonics. This was a close brush with catastrophe. Emergency officials are now in overtime mode, scrambling to assess damage, reroute transport lines, and stabilize infrastructure. But they are also preparing for the thing no one wants to say out loud, the third quake. You can feel it in every press conference. The tension, the unsaid what if. Will this be a doublet or the start of a seismic domino chain? Geologists are already watching nearby segments, areas like the Nemuro seismic gap in the Sanriku coast, with a wary eye. These areas have gone quiet for too long. And if there's one thing earthquakes hate, it's silence. A quiet fault is a stress fault, and a stress fault is just waiting to scream. But let's zoom out for a second.